Alright, so today we're going to look at dependent events. Dependent events literally means that the probability of one event happening will affect the probability of a different event. Now, these questions aren't necessarily clear in the exam whether it is dependent or independent events. So you have to really read the question carefully and infer it from there. So everything you've been doing so far to do with probability trees have been independent events. With dependent events, as I said, depending on what happens on the first event, the probabilities for the second one change. Classic example. Let's say I've got 8 donuts in the fridge and I've got 5 chocolate donuts and 3 jam donuts. And I'm going to take 2 at random from the fridge. I'm going to take one, eat it, and then I'm going to take another one at random. I don't mind whether it's chocolate or jam, I just want a donut. Now, here, if I'm eating the first donut, after I take the first one out, there's not going to be 8 left, there's going to be 7, right? So that's why, depending on what I pick first, that will alter the probabilities of the second donut. And we can model this situation. The first event is the first donut. And the first donut can either be chocolate or it could be a jam donut. And the probability of the first donut being chocolate is 5 out of 8. And the probability of the first donut being jam is 3 out of 8. Now we move on to the second event, which is the second donut that I am going to eat. If the first donut that I had was chocolate, what's the probability of the second donut being chocolate as well? Well, now it's only out of 7, because I ate one already. I didn't put it back. That would be weird and disgusting. But now, I don't have 5 chocolate donuts left. I've got 4. So it'd be 4 out of 7. And the second donut, well, it is going to be out of 7. So the first one was chocolate. What's the probability of the second donut being jam? Well, I've still got the 3 jam donuts left, so it's going to be 3 out of 7. Conversely, or alternatively, if the first donut that I picked was jam, the second one can either be chocolate or jam. What's the probability of the second donut being chocolate if the first one was jam? Well, it's going to be out of 7, because I've already eaten one. How many chocolate donuts are there left? Well, it's still the 5 one. Still the 5 chocolate ones were there, because the first one I picked was jam. And the probability of the second donut being jam is 2 out of 7. So this is how I would model the tree, and as you can see, it's called dependent probability, because these 2 probabilities are not the same as these 2 probabilities here, because they depend on what happens first. And this is how you model it, but then you've got the usual questions. What's the probability of picking 2 chocolate donuts? So the probability of chocolate and chocolate is and, so probability of chocolate 5/8 times, because and means multiplying probability, the probability of the second one being chocolate, which is 4 out of 7, and the answer would be 20 out of 56, which I could simplify if the question asked me to or not. And equally, they could ask me, what's the probability that I eat one of each flavor? Well, it's either chocolate and jam or jam and chocolate. So I need to model those 2 situations. So the probability of chocolate and jam is chocolate 5/8 times 3/7 is 15 out of 56. So that's the first one chocolate, the second one being jam. But I could also do the other way around. The first one could be jam, and the second one chocolate. So the probability of jam and chocolate is 3/8 times 5/7, which is also 15 out of 56. And if I can do that or that, what do I need to do with the two probabilities? I have to add them together. So the probability of having one of each flavor is 30 out of 56, which could simplify to 15 over 28, whatever that is. But anyway, that is how you model, this is how you model dependent events. And like I said, the probabilities of the second event are different because they depend on what happened on the first event, and then you just answer the usual questions. Two of the same, one of each, that kind of stuff. This is a simple case. You could have a three-branch tree at every option. It gets a bit more complicated. So that could happen, but in general, this is it. So please copy the example out, understand what I've done over there, here, and any questions, as usual, let me know. Right?